foto da resolução bem passo a passo, assim, tá? Pra ver como é que você desenvolve.
Ok.
Tu vai lá no Japão fazer essa prova?
Aham,
Caraca, velho, que massa.
pois é.
Aproveita e captura um Pokémon pra mim lá. Coisa massa no Japão pra fazer. Your English is excellent, I suppose.
Yeah, yeah.
We can try our class in English if you want.
If you agree, yes, I can do that.
Okay, but my English is not so good than yours, so you need to be patient with me.
Okay.
So when you finish, you just send me a photo, okay?
Okay. I am not that sure how to start the answering the question.
Okay, because I suppose you don't know logarithm.
Logarithm? No, I think not.
Okay. In Brazil, logarithm is a subject in high school, so I suppose you don't
Yeah,
know.
okay. Yeah, I don't know that.
Yeah, but okay, no problem. I teach to you. It's very easy.
Okay.
Suppose this is a problem for you because actually is a lot of memorizer things to you do this. But okay, I will teach you for this question only. Okay, we have these two things and this sum, so we need to know the value of A and B, of course. But let's take the value A. I suppose the only way to do this, oh, it's the only way, is using logs. For example, we have this 11 power of A equals 803. B. Well, we want this thing here. This thing is in the exponent of 11. We
Yes.
need to take this of that place and put in another place. So what's the mathematical function do this for us? Is the log. We need using log in that way. We apply log in the both sides of the uh, equation.
All right.
So when we do this, we have a property of logs. The exponent of the value inside of the log goes down. Okay, so you can write this in this way. Pay attention. This is a number, and this is a number too. It's not a variables incognitas, right?
Right.
So we know the value. The value is log 803 over log
11.
11. Yeah. So probably in our mathematicals here, we will simplify things and we know the value without logs. Okay, but we
Okay.
need to do all the things. So in that moment, we have A. We can use the same idea to take the value of B. So we are smart. So just write the things using the same idea, okay? Because it's the same thing. Just change the numbers, right?
Right.
Okay, so we have these two things to A and B. So we need sum these values. Okay, pay attention. We have A and B in the downside of the fraction, right?
Right.
So I suppose you know the properties of fractions. So if we have a fraction of a fraction, I will change the letters. This is the same thing of this. Do you agree with me?
Yeah.
Okay, amazing. Because we have fractions to A and B. So we can use this idea. Our sum, oh my God, our sum will be log 11. But teacher, what's log? You don't need to know now.
Ah.
What we need is do this question. But in the future, I can teach you. It's very easy, actually. It's the inverse way of potential exponents. The inverse way of exponents. In another moment, I teach to you. Okay. So we can sum these things, right?
Yep.
But we need to know a very interesting thing. We have another logarithm property here because we have a sum of logarithms. When we have a sum of logarithms, we know this is the same thing, the multiplication of the inside part, right? Is a property. You need to memorize this, like the
Okay.
other properties, like a lot of properties of potentialization, you know. Okay, so now we need to know how much is 11 times 23. I know is 10 times 73
Plus
plus
73.
73, right?
Right.
So how much is this? I don't know. Uh, um, 803, right?
Right.
Oh my God, this is very interesting. It's the same number.
Log 803 over log 803.
Yeah, it's the same number, right?
Right.
So
It's just one.
yeah,
Okay.
just like that. As I already say to you, this is a number, and it is a number two. When we have two numbers, two equal numbers, we can cut, and we have the number one. So the answer is one. Oh my God, just one. Okay,
Okay.
very easy. So you need know, we need to know what is how work with log. Okay, in this moment, we need to memorize some rules because I suppose we will need this in your test in Japan. But in this question, we just need to know when we have exponent without relation, because I suppose you already learned something like this: two two a is equals four. So, or better,
Yeah.
you know a is three, right? Because
Yes,
this
yes.
is. But sometimes we have situations when we don't have the relationship. For example, here we don't have a number to put in a. This number will be equal 803. We don't know. So in that situation, we need to know logarithm. Okay,
Okay.
the logarithm here helps us to find the value of a uh, using properties. A in the exponents. A goes down. So we have this number for a. It is a number. It's a strange number, but it's a number. If you put this in your calculator, you will have a number. This two, so a number. In
Okay.
uh, um, in your test, will you use calculator?
I don't think so. I
I,
think
sup-
calculators are not allowed.
I suppose not, because probably this will be right here. Something about calculator, but I have a hint for you. You need to search in YouTube or in ChatGPT informations about this test. Okay,
Yeah.
it's very important.
I was trying to search some things about the test, trying to know how to do some questions to learn new things, but I couldn't find a lot of things. I think because IMO is not a very now known mathematical Olympiad in the western part of the world, because it is mainly just for Asian countries, but some other countries are invited, like Brazil. So I couldn't find a
Um,
lot of things, but ChatGPT really helped me to search for things. But I didn't ask him it about the calculator.
yeah. It is important to you know the questions. It's very important, obviously,
Yeah,
but it's very important to you know how will be the test, the rules and the things you can use and the time. This is very important too because we need to be confident to the test. Okay.
yeah.
Okay, man. So let's go. Let's go to the next one. Um, this here. Find the remainder when this number is divided by 9. Okay, this is very cool because we have a lot of properties about exponents to do this, right? So I want you to try a little bit. When you finish, you you talk to me, okay? But now
Okay.
I need to go to the bathroom.
Okay.
Just a sec. Well, do you do something? Because this is
Not
a very hard problem.
quite. Yeah, I am not sure how to start it either.
Amazing. So I will start to you. Because here we have a situation, an interesting situation. We have 803 and some exponent divided by 9. What's the hint here? Is the fact we have the division by 9. Because when we have this division by 9, we can do the next situation here. We can sum the algorithms of the number. We take the sum, 11, and we can divide 11 by 9. Will be the same rest, the same remainder, okay? So if you divide it by 803 by 9, the rest will be 2. But
Yes.
is equals, you divide it by the sum of the algorithms. Okay? So it's
Okay.
easy, is easier for us. Because we can work with 803 or 2. Because we are interested in the rest of the things. I will show to you. For us, work with 803.1121 and divided by 9 will be the same thing we work to 11 by 1 divided by 9. The rest, in English we say mode, will be the same thing. Okay, when we divided this thing, for example, what is the rest here? Obviously, is 2. Because we have 2 divided by 9, we don't have a division at all.
Yeah.
So the rest is 2. We only have a rest. Okay?
Okay.
And here, if you divide it by 803 by 9.
You also have rest too.
Yeah. So this structure will be the same. For example, if you have, because this is a property of the number 9. Number 9 is a mystic number. The Pythagoras is a lover of the multiples by 3 because we have a lot of strange properties. For example, if we have, in this case, 2 to the power of 2 divided by 9, here, obviously, we will have the rest equals 4. Okay?
Okay.
And here, well, we can use the calculator to show to you, just to prove a lot. For example, here, divided by 9. Well, we don't have a rest, but if we use the mode is the value of rest, okay? So
Okay.
mode 9 will be 4. 4, okay?
Ah,
So this is the strategy here. This question is not easy. So we need to know some rules, some things, different things to do these things, okay? So, but it's important to you have this ansiedade before know the answer, because we will memorize easier, okay? So we have rest 4, here for 2, so we can work with the mode, the rest, in the situation I say to you here. So if we want 80, the rest, the 80 to the power of this, we want the rest, the remainder, right?
yes.
So
Right.
will be the same thing, the remainder 2 to the power of 2017, right? So,
Right.
but we don't know because this is a very big number. So how can we work with this? Doing the division first for a number, we bring to us the answer. But what's the number? Because this is the rest. We don't work with rest, okay? But we can use another situation, another strategy, the pattern strategy, the pattern about the rests. For example, what is the rest if we take this one? The rest will be 2, and
Yes.
here 4, and sorry, and here will be 8. Here we have a number bigger than 9. What will be the rest?
2 again.
Will be 7,
So-
because 16 over 9 is will be 1. 16 negative 9 is 7.
Yeah, sorry.
Yeah. So we want
I got lost a little bit in my thinking, sorry.
yeah. It's a lot of things because we never work with the rest, right? But in this problem, we uh, stick about the rest because this I am not using the equal, but the equivalent because we are work with the rest. Okay, rest. Uh, okay, so we need find a pattern in these rests because we know the rests have a pattern. For example, if we have, for example, 4, we divided by 4. So, for example, 1 divided by 4, the rest is 1. 2, the rest is 2. 3, the rest is 3. 4, the rest is 1 again. Sorry, 0. And 5, the rest is 1 again, right?
Right.
6, 2 again. 7, 4 again. Então, 3 again, sorry. So, when we are working with remainders, we have patterns of values of rest.
Yeah.
Okay, so probably here we will have a pattern too. Let's find this. 2 to the power of 5 is 32 divided by 9. 5.
5.
The rest is 5. You can do this math for me, but I know it's 5 because I do this math in my mind. And here, 64 over 9 will be, let me see, 9 plus 7. Oh my God, 1 again. We find, no, we don't have 1 yet. Okay, shit. But okay, let's try the next one. 100, 128. We need a pattern here because we are in the limit. Okay, 1 is the limit here. 9. 1, 3, right? 8, 4, right?
36.
2. Okay, we have a
Repeated
pattern.
pattern.
Yeah, we have this pattern here. So after the 6th term, the pattern we have a pattern. So we have a cycle. Each 6 potentials, right? We have this cycle. Because if we do 2 to the power of 8, we have 4 and 8. Okay, so we have ever this pattern in each 6 potentials. We have this cycle. Okay, so we need to know where will be 2070 in this cycle of 6. What we can do this just doing the division.
Yeah, dividing by 6, and then the rest would be 1.
The rest will be 1, okay? So uh, we have the rest of very interesting this, okay? So the rest is equal the rest of the first thing exponent 2, because we have 1. So we have the same thing. In other words, do this is the same thing do this. Okay?
Okay.
To rests, because we have the pattern. Okay? Do this for the remainder is the same thing do this for the remainder. The number are different. Okay? But the mode, the rest, the remainder is the same. Okay?
Okay.
So you do the rest. We are talking about rest. The rest of this is the same thing the rest of this.
Okay.
In other words, 2. The rest of this is 2
Yeah.
when we are dividing by 9. So the answer is 2. Okay? In other words, the remainder of this number divided by 9 is 2,
It's 2.
because we have a lot of things here. Okay? But this is the first strange thing, but you can. I teach to you this for bigger numbers, but this is very easy to understand. We have the
Yes,
rest
yes.
too, okay? So we when we are thinking about the rest, these two things is the same. Here we have how can I say? We have an idea to use in the rest of the question. Okay, we have this pattern. So I find a pattern here, here too. Okay,
Okay.
so this question is not easy because use a lot of things about properties of numbers, like the pattern of the divisions. But when you understand, it's easy, right? It's
Right.
just divisions and things like that. But we need to understand something. When we have a test like this international test, and in Vestibular too, and a lot of other things, the teacher who create the question don't want you do long maths, okay? So
Yes.
the guy put this thing here. He doesn't want you really do
Yeah,
this
yeah, yeah.
to understand. So probably we have things to um, uh, facilitar,
To make
to
it easier.
take it easier our questions. Okay, this is very common, very common. So mainly when we have potential problems. Okay, we ever uh, can find a pattern to do this thing easier. Okay,
Okay.
so memorize this. This is very important. Let's go to the sequence. Let me see if positive integers xy satisfy the following question. Uh, find the sum of possible values of y. So we have this interesting equation here when we have x and y in the same equation. It's very different.
Let me see.
Let me see. You
Positive
can
integer.
can think a little bit, and I will think too. So when we have some idea or any idea, you say to me, okay?
Okay. I think I got an idea on how to answer the question, but I am not sure how to go on from the point I stopped because, like, I saw the question, I saw the equation, and I thought, this resembles a second degree equation, but then b would have to be minus y.
Okay. Okay, I understand your problem. And we have we um we really have a second degree equation. I don't know. Because if we, for example, isolate y, the letter y, the variable y, we will have this thing here. I don't know if you already did this, but we will have this, right? I just isolate y. And we don't have a, sorry, is x here. And we don't have a second degree equation here.
No,
Because,
yes, I thought of a second degree equation in the way like
yeah.
in the first one that they equal zero and like, but
uh,
then minus y would have to be the b.
I understand. I understand.
And then I tried to do it, try to find delta, I tried to, but then yeah, I didn't get.
Okay. A delta depends by y. I understand.
Yeah,
But I suppose it's not the strategy here.
yeah, yeah,
Because, for example, we have this equation. This is more cute equation. And if y is integer, like the question said to us, y is integer, right?
right.
So the value of x,
Must be a multiple of 3.
or no, no, because if we put, for example, 6, the multiple of 3, this will not be an integer
No, yeah,
number,
yeah, yeah, yeah.
right? So we have, I suppose, two values for x only. X equals 1, x equals 3,
Yeah,
right?
I was trying to say that, but I got again.
Because we need the positive 2, because another possibility will be 1 and x equals minus 3, minus 1 and minus 3. But if you put negative values here, you will have negative y, right?
Right, and we can't have negative y.
Yeah, so we have these two possibilities. So we now we you know this, so you can try finish the question, right?
Right.
When you finish, just tell me.
Okay. The values of y would be 7 and 13, right?
Yeah, you can just put the values here and obtain the y's.
Yeah.
Find the sum of possible values of y. So we just need sum the values, right?
Yeah, 20.
So very easy, very cool. But in this entire class, you don't send me, you didn't send me any photo. It's very important to me to help you. You send photos of your maths. Okay. But okay, was our first class, so this is normal. That was the easiest question today,
Yeah,
man.
yeah, the easiest question so far.
Yeah, because they are not. Was very hard, but we know that have a strategy, the periodic strategy, and here, well, for me it's easy, but you don't know logs, so to
Yeah.
you it's hard. But okay, man. Oh, a photo. You is very organized. So this is cool. This is cool. Amazing, man. Amazing class. So I hope you do more classes. Okay.
Okay.
So bye bye, man. See ya.